Okay, let's let's continue our discussion. And the next topic we are going to discuss is relations. So first, let's see some examples. Remember, when we talk about ordered pair, we give example of FIU, Miami, UCF, Orlando, and UF as well. Okay, you can see that for each of these three pairs, ordered pair, there is some relationship between the first element and the second element. In particular, the first element is a university and the second element is a location. So we say object A for ordered pair AB. Okay, we say object A and object B. This is not a rigorous definition. We will give a more rigorous definition later. So we say have a relation R if A and B are related in some way. Related. Let me be more precisely, mathematically, in some mathematical way. Defined by R. Okay. And then we say we will write A, R, B. Okay, it's very important that usually A and B are ordered pair. So we A, R, B doesn't imply B, R, A. It's not the same. Okay. For example, we can say FIU is located in Miami. We cannot say Miami is located in FIU. Okay, so this ordered pair relation is a directed relation. So in this example, we can say FIU are Miami. Sorry, UCF are Orlando, and so on. And this R relation actually means something like add. Okay. And then we can also say FIU are North Miami because we have another campus in North Miami. And you are going to see later why we care this example. Okay. And what about the relation between FIU and Orlando? We know our FIU is not in Orlando, so we can write, we put a slash across R to denote that FIU and Orlando are not related by R. Let me give you more examples. So let's define R to be the relationship of less than or equal to. Okay. And then we can say 3R4 means 3 is less than or equal to 4. We can say 3R3, and definitely we don't have 4R3. Okay. Another example is if we define subset relationship, and then we can say the set 1, 2 is a subset of 1, 2, 3, and therefore we can replace this subset using this R notation. And the last example I'm going to give you is, say I define this to be adjacent. And then we can say Florida are Georgia. And Florida are Alabama. And what about Mississippi? MISS. ISSIPPY. Mississippi. Sorry. MISSIPPY. So Florida is not adjacent. Okay. Mississippi. Let's move to next page. So how can we define, we could give mathematically satisfactory definition. So you can see here, so what is the definition? For relation, we have ordered pair. Each element in the relation is ordered pair. So therefore, you can imagine that the best way to define relation is using this Cartesian product and define the relationship between is a subset of A cross B. And for example, in this, maybe it's, okay. So maybe we can draw a diagram like this. So this FIU, this is UCF, this is UF. And then suppose this is Miami, this is Orlando, and this is Kingswell. Okay, so which of the dot satisfy our property? Okay, so now if I have this, suppose I call this is my set A, this is my set B. So I have A cross B as we discussed in the at the end of the last video. We have A cross B contains 9 elements. However, which of these 9 ordered pair are related by this relationship of add relationship? So if I define this located in, okay, so let me change the color. So I know that this dot satisfies this property. UCF is located in Orlando, and UF is located in Gainesville. And all other 6 points don't satisfy this relation. And therefore, it's clear that we should define mathematically that a relation is a subset of Cartesian product between 2 sets. Okay, so let me give you the rigorous definition. So let A and B be set. Sets. A relation, we say a relation R from A to B I think, sorry, I think I don't want to say two set. That just be set, because A and B can be equal. A to B is a just subset of A times B. So this definition is very, very general. So because you can imagine that if I want, I can define another relation. Okay, let me. I can use a yellow dot, a yellow color. If you can define any relation at your will. For example, if I define my relation is FIU and with Miami, FIU also Orlando, UCF. I don't want UCF to be related to Orlando, but I want UCF to be Miami and Gainesville. And maybe I want UF to be related to each of these three. You can basically, you can define any relation at your will. And for this relation, I don't have a very clear meaning. What the relation stand for? It doesn't have a clear meaning of located in, but that's also a legal relation, and that is the power of this definition. Is any subset of A cross B, and so given an ordered pair, xy belongs to A times B, we say X is related to Y by R, denoted XRY, if XY is in this relation. Okay, remember R is defined. Sorry, R is just simply defined a subset of A times B. And then we call A is the domain of R. And B is called codomain of R. Okay, let's move to next page. And sometimes it's very intuitive to draw a diagram. This is called arrow diagram. Of a relation. This diagram is defined as simply we draw an arrow from X to Y, if and only if X are Y, and equivalently if and only if the ordered pair XY belongs to R. Okay, let's see an example. Okay, actually we are going to see two examples. The first example, example 1, suppose I have this A equals 1, 2, 3, B equals 1, 3, 5, and I define with my relationship X, R, Y, if and only if x is less than y. Okay, then typically we draw a set like this. I put 3 dots to denote 1, 2, 3, respectively. This is my set A, and I draw another 3 dot, 1, 3, 5. And this denote my set B. Okay, let's see. So 1 is related to 3 by R. So we draw an arrow like this. 1 is 1 to 5. And what about 2? 2 is also I'm going to have to draw an arrow from 2 to 3 and 2 to 5. And from this element 3 in set A, we only have 1 arrow from 3 to 5. Okay, let's see another example. This is the arrow diagram. Another example of how to draw an arrow diagram. In this example, we have the university location example. Suppose my set A is FIU, UM, UCF, and UF. And on the right-hand side, this is my set A. This is my set B. I have Miami and North Miami, Orlando, Gainesville. And now I define my relationship is R is X, R, Y, if and only if X is a campus in Y. And so I changed a little bit about the definition. And so that now FIU has, because FIU has 2 campuses, one is in Miami, so I have an arrow from FIU to Miami, and another arrow from FIU to North Miami. And UM has 1 campus in Miami, and UCF has campus in Orlando, so from an arrow from UCF to Orlando, and finally an arrow from UF to Gainesville. Okay, and that's what I want to say about the relations. And I'm going to stop here for this video. Thank you.